Everything is good. Okay, first in French. Bien, bonsoir à tous. Merci d'être venus ici ce soir. Merci aussi à Internet qui nous regarde en direct ou en différé. On est très heureux de recevoir Marc Verbos de Verbos Electronics. Il y avait un indice dans le nom. Voilà, les constructeurs américains ne viennent pas souvent en Europe pendant une visite, donc là on profite évidemment grâce au Super Boost de pouvoir profiter d'eux quelques instants. Donc voilà, on va maintenant switcher en anglais, donc j'espère que vous n'avez pas de soucis avec ça. Si vous avez des problèmes, vous me dites voilà, j'ai pas compris ça, il pourra répéter et on pourra traduire éventuellement s'il y a moins de soucis. Voilà. So right now we can switch in English. In English, okay. Thank you very much to be here. It's a great pleasure to have you on board.
Pleasure to be here.
And well, let's introduce you and then all of that. Okay. Merci à lui d'être venu.
Okay. So my name's Mark Verbos. I'm came here from New York City. I am for the last 20 years an electronic musician and synthesizer building technician, engineer, whatever. The focus for my company, Verbos Electronics, which has been operating for the last 2.5 years, is modular, analog, modular Eurorack format equipment. And the focus of what we do is on purely analog, all made from discrete parts kinds of stuff. With a focus on sort of old style of creation, so a lot of discrete transistors and kind of classic styles of electronics, but also a focus on musical devices where the interface is actually the driving force behind it. So for the last 15 or so years, I've been doing a lot of servicing of vintage synthesizers, particularly Buchla instruments, and became sort of a specialist in working on vintage Buchla instruments. So a lot of what I've learned from those instruments is applied to my devices. They're not clones, but they draw a lot of inspiration from those ideas. And I try to bring together some of what I need as a musician, what I want to do with the devices, and try to make something that's from that perspective. So
maybe because it's interesting what you've said. What's the main difference between maybe an old way of making a module and a new way of making a module right now? What did you choose to change to achieve the new things?
Well, one thing that I totally glossed over before is that we actually manufacture all of this stuff in our own shop. We have our own manufacturing in New York City, and that allows us to go from an idea to a finished product very quickly in a way that most of the boutique manufacturers don't have the possibility of. So we're not farming out the work. We actually have people in our own shop, where we have a pick-and-place machine and this kind of thing, but also the finishing with panel parts and stuff like that are done by hand. So those are done by people in our facility. But as far as the changes, what make these modules unique compared to other modules?
Not maybe other modules, but Buchla, because your main.
Okay, of course. Well, first thing is that in the world of synthesizers, or at least modulars, you'll hear a lot about this idea of East Coast versus West Coast, which I think in Europe is an abstraction since you don't have these coasts there. But it really comes from the idea that in the beginning of synthesizers in general, Bob Moog was in New York and Don Buchla was in California, and they were both developing the first synthesizers at the same time. And when they came out, they had each taken different directions, different choices that were made, and those different choices came to be known as the East Coast or the West Coast philosophy. So the primary thing that the West Coast philosophy or the Buchla philosophy does that's totally different than the way that most everybody else did was was that rather than using all the time using rich basic waveforms like the waves that come from function generators like saw and square, and then filtering them to create the dynamic of the tone. The West Coast way of doing it was with wave shaping or with frequency modulation or some kind of technique to start with a basic wave like a sine and then manipulate that wave to create more harmonics rather than the other way around. But also wrapped up in that kind of West Coast philosophy is the introduction of random signals was initially from that school of thought, and envelope generators. In the East Coast world, you find attack, decay, sustain, release envelopes that are pretty standard, whereas in the Buchla world, you never had those. So either they'll be really simple attack, release envelopes, or they'll be longer, extended ones with multiple stages and voltage control and a bit more complicated to use. Some of the things that are important to me that I think really separate what I'm doing from what Buchla did are that that I don't ever want to have anything hidden behind a menu. So pretty much universally, everything of mine has one function per control. And a good example of that is in this module, the voltage multistage, which is a sequencer that can be used as a multistage envelope generator or as an LFO or a sequencer or whatever, that in some ways shares functionality with the Buchla multiple arbitrary function generator. But in Buchla's way of doing it, that all of the power of the module is hidden behind switches and selecting a stage and putting it in, which I find to be really not musical, very it requires a lot of thinking and a lot of planning, and in the interest of being more experimentation driven, I've taken those functions and put them into a format where just with patching and with switching right from the front panel, it can do all of the same functions, but without being hidden behind something. Maybe another example of that is that in the new module that I'm going to show, one of the new modules I'll talk about later, the random sampling, I have a fluctuating random voltage source, which is similar to what Buchla did in the source of uncertainty, but he has a range that only allows it to go from the clock. It's a random voltage. It's essentially a clock followed by a sample and hold of noise followed by a filter that tracks. But the range of it, in his case, only goes from about a cycle a second up to about 50 hertz. But in this case, I have it so that it can go in that kind of range. Give me an example. It can cover all of that range and then some. So this can go down to so slow that it's taking 10 seconds per cycle, and so fast that it actually becomes the sound flow. So in opposition to Buchla's idea that there should be signal sources and there should be control sources and those should be separated from each other, I don't always follow that, because there's flexibility in here in one set of controls where I never have to switch modes or change the way that it's working. I can just change my mind and start to use a control signal as an audio signal. So
That's cool.
yeah. Do you think it'd be good for me to talk about each?
Yes, do you have some question about the beginning, about the creation of the brand or something like that?
Do you think to continue to release new module in Buchla format or not?
Well, this comes from the fact that, well, before I had this brand, I was doing, I still am doing a lot of servicing of old Buchla systems. That hasn't stopped. And I'm the tech for several universities and most of the big individuals who have systems, and 200 systems are where my focus is, and there are only around 30 original 200 systems in the world, so that's a pretty specific group of people. And I started to make custom modules that worked in those systems. The problem with that is that it's such a small audience that most of those modules I've only made 7 or 15 or something like that. So in some cases, the ideas that are in here were evolved from things that I did in that format, and in other cases, I've only made it for this. I continue to make those modules if somebody wants one, that they're not discontinued, but I'm not at the moment develop anything new for that world, not because I turned my back on it, but just because my primary focus is on this, and now my days are pretty busy running the shop and actually manufacturing in addition to designing. So maybe.
And it's also why the difference of the price is so high here, because
the difference is because these are actually made in quantities, and they're done with a machine. And for just as an example, the metal work to make a panel, if I make 500 of them versus making 5, it's a huge difference in price, and that applies to every step along the way.
But for you, at the end, it's the same. For example, the difference between your harmonic oscillators and the Buchla format, there is only to sing more on the Buchla format.
That's true.
Then,
well, part of that is that the size is different. So in the Eurorack world, you only have 3 rack units of height, and in the Buchla world, you have 4 rack units of height. So it already confines everything a little bit, and I think it's important to organize things in a way where they're easy to use, rather than trying to get every feature that comes to your mind into a small space. So in the process of porting that idea into this format, a couple of things were lost, and actually some of the circuitry is done in a different way too. So it's not just the same module changed. In the harmonic oscillator that I did for the Buchla world, all of the mixer is done with Vactrols, so they're essentially 10 low pass gates, and this is really expensive to do and requires a lot of hand labor, and also the Vactrol now has been discontinued in August.
yeah. So it's not, at the end, it's not exactly the same.
Exactly.
Okay.
And actually, even in this case, the core of the oscillator is not exactly the same either. These all the oscillators that are in this system are the cores are made from discrete transistors. So in a way, they're more similar to the older Buchla oscillators than they are to the 259 or something like that. So it is a little bit different. I wanted to get the general feeling of that module and bring it into to this format, but I didn't want to be trapped with trying so hard to bring that same idea into a smaller space with a more limited budget, because inside of a Eurorack system, I don't think that a module that's 1,700 euros works anymore, because it's a format where people expect the prices to be lower. So certain corners are cut to make it more manufacturable and more require less personal attention to each one, because if everything has to be tweaked, over and over again in order to get it, there's so much human labor in that, and in those I did all that labor myself, whereas now a machine is stuffing the circuit board. I mean, it's my machine, but it would take me 15 hours to stuff the circuit board on one of those, and this is done in 4 minutes on the machine. So it's a different thing.
Yeah.
Okay, I think we can go
on. So I'll just go through each of these that are here. Can you actually see these from there?
No, but
Is there a way to make it so that we can actually see it?
Not really.
Okay.
We should install a camera.
Yeah.
But it's not done.
Or we can stand it up, or
let's
looking coming
try.
closer. I don't know if it blocks
Yes.
the view.
Vous pouvez vous rapprocher autour hein, si vous voulez. It will be no on the camera, but ah, par contre vous allez être sur internet si ça vous dérange
It's already getting pretty warm up here, so.
Rapprochez-vous, rapprochez-vous.
Moi, je peux être sûr.
So, is it okay if I turn on?
Yes, sure.
So, well, just starting up here, the complex oscillator is a good example of a lot of the VUCA ideas being brought into this format. Again, it's not a clone of a VUCA 259, but it's arranged, and the oscillator cores are discrete transistor based, and because of that, they're pretty organic. They're based on the VUCA idea rather than to have the outputs of the oscillator just be typical. We have triangle, square, and sine, but we also have a wave shaper section that allows for blending together wave shapes.
When you say wave shape, you literally mean you're clipping, you're doing a 10H type of a shape.
Yeah, you have the controls that you have here are for timbre in general, starting with a sine wave, fading up, and then you have a control of low or high order harmonics.
Okay.
So when you're in the high order, you do have square and saw. But when you're in the lower order, you're actually folding the sine wave up by clipping it and mixing out of phase clip version together, and sometimes it's called a wave folder or a wave multiplier, and the sine wave is driving that. What's nice about this system is that, which is an inherently West Coast type of idea, what's nice about it is that in a lot of cases, sounds that we might normally expect from an oscillator followed by a filter can be created just with this module alone. And all of those parameters, all of the parameters over here can all be automated with voltage control too.
We're not hearing a filter at all.
No filter in the chain.
More like a filter with a resonance at all.
Exactly. Particularly in the lower order harmonics where this wave folding is happening, it really does have the quality of a resonant filter being swept. So also built into this oscillator is a dedicated modulation oscillator. So it can, just from the flip of a switch, can add amplitude modulation or frequency modulation, and from whatever shape.
Your F that we're hearing logarithmic.
Yeah, exactly. Good ear.
Yeah.
In this case, the waves on the modulation side are unipolar, or they are only the positive side. They start from ground and go up, and that means that, and they're going into the FM. So if you create an interval, then it follows the note you're playing. So as opposed to linear FM, which would have a different amount of effect as you go up the keyboard. That's just a choice, one way or the other. What I like about the exponential FM is, in this case, is that if you create with the square wave, for instance, you have two notes that are playing.
Right.
That if they're an octave apart, then when you play a higher note, it's still modulating an octave apart,
Yeah.
which I guess both ways of doing it have merit and have certain circumstances where they work better.
The pitch change is what usually gets me. But can you actually? This is a side question.
Yeah.
Could you do linear with?
Well, there's a linear FM input on the oscillator, but it's just not in that automatic patch there. So if you wanted to use this modulation oscillator to do linear FM, you and it has it's capacitor coupled, the linear end. So there's a 2 seconds or something where it bends it off, because in this case, this oscillator, being that it's unipolar, is initially offsetting the pitch by a little bit, and then it's correcting. But also in a situation where your built-in modulation is linear FM. If you're using it for a high frequency, it works really nicely. It doesn't change the pitch. But if it's AC coupled and then you try to do something slow with it, like a square, you'll hear it like fading back toward not modulating in as you're holding. So I'm not. That's actually what a Buchla 259 does.
Okay.
Yeah, which I always hated about it. Yeah, so choices.
Yeah.
But
do you mean the first oscillator, the modulator, is unipolar?
yeah, it's always positive voltages.
Okay.
It's the right one is positive and negative voltages, or centered around ground. But since this is used primarily for modulation of stuff, it's in the positive region.
Okay.
All the controls on these have their attenuverters or inverting attenuators. So if you want to control something with it that you want to go down, you can just go the other direction. Or
I thought it was unipolar only in the using a rectifier or something, only in the patch.
right, it's I don't know. People will disagree on this one, which way to go. But I think if it's a control signal, it should be all positive. But if it's an audio signal, it should be positive and negative. But this is also a sort of hole in the Eurorack standard. Last week we had in Berlin we had a meeting with 6 or 7 people who make Eurorack talking about some things that don't actually have standards. And one of the things is that control voltage ranges aren't really standardized. Envelope generator sizes aren't, the size of the voltage swing isn't standardized.
Yes.
And everyone in the room disagreed on what it should be, so I don't know that it actually went anywhere. I don't know, mine are all 10 volts.
I would like higher voltage everywhere.
Well, that was my argument, was that if you have a 10 volt swing coming out of your envelope generator, then you can plug it into anything and turn it down if you want. But if you only have 5 volts coming out of it and the input that you're plugged into is expecting 10 volts, then you can never open it all the way. And there's some incompatibility with modulars between manufacturers where VCA is expecting 10 volts to open, and then you can't use it with something that only puts out a smaller one. Yeah. I actually have experienced a problem like that in the world of Buchla instruments, because the 100 series and the early 200 series used 15 volt swings of voltage, and the later 200 series and the 200E only use 10 volts. So you can actually, in that case, with modules from the same manufacturer that were made 2 years apart, have the low-pass gate not open all the way from a certain. And I've even seen it within systems that came out of the Buchla factory, configured with envelopes and VCAs that don't work together. Strange, but
I thought Buchla was more consistent.
yeah. I wrote on. I have a blog where I wrote about like fixing Buchla stuff before, and one of the posts that I put up was I called it, the nice thing about standards is there are so many to choose from. Because each time he made a new series, he changed the way that the power voltages were, he changed the way that the signal level was, and everything. So you can't please all the people all the time.
I think the main problem, I don't mind having like very different approaches in the URAC world. I think it's a richness in itself, but what I don't like is the lack of specifications on with a lot of modules. You don't know really what's going on as far as voltages out, and it's sometimes a real pain to be aware of those.
That was part of that discussion too. Is that one of the things is the idea that there should be a kind of certification for what it means to fit the standard. And in order to fit the standard, you would have to comply with all of the rules rather than just, that it fits in the rack, or that it uses the same kind of power connector. But the power connector is a problem too, because different brands label them different ways and have tabs on different sides and all sorts of things. So it's a bit that the power actually is the number 1 concern in the discussion. So anyway, so the random sampling is a new one, so we'll get to that last. The dual 4-pole is actually filters, which in a sense goes against everything that I've said before. But the circuit that these are based on is derived from a Buchla 100 module, where he made these 4-pole high-pass and low-pass filters in a very strange way, using diode-connected transistors. It's the only one that was ever done this way, with this strange configuration. And since, as far as I can tell, he made about 5 of them, I thought it was interesting to develop the idea a little bit. So these are pretty rough, old world kind of stuff that are kind of noisy and unpredictable. But another thing is that I've added resonance to them, which they didn't have originally. I'm not really a filter specialist, but one thing that I like about these is that you have these reversing attenuverters, if you will, which allow for up or down modulation on any of them. And another interesting thing is that the nature of this the filter core is that it's very mismatched stage after stage. So one of the things that's required in order to make self-oscillation in a filter, so these are what they call cascade filters, where it's 4 poles just in series. One of the things that's necessary to get self-oscillation, or the kind of whistling sine wave, is that the stages are actually matched, that they're hitting the same frequency. So because this design is so messy, they're not matched at all, which means it's not possible for it to self-oscillate. But what I found is that actually makes for a very wet kind of TV303 type of of resonance that actually will never whistle, but it makes this really liquid, which is really the result of it not having the matching to ever self-oscillate.
So the cutoff stages for all of the one poles are slightly different? Or
Yeah, it's just an act of God, because the matching is it's impossible to make this system really work well. So
Okay.
it takes actually way more gain to get it to resonate at all than it does in a traditional 4-pole cascade type situation. But an interesting thing is that there are some cases, like the TB303, where intentionally one of the poles is offset a little bit because it disrupts the phase relationship and makes it not possible to make it self-oscillate intentionally. But this is just what happens when you take this design and you add resonance. It'll never I mean, you can get it to self-oscillate if you add, like, the 100 times gain or something, but in a reasonable configuration, it won't. It'll just sound like that, really distorted and really like wet resonance.
How are Vactrals responsible of the sound in that specific?
Vactrals?
Yes.
None.
No.
No, it's
Okay.
using transistors.
Okay.
I do have optical elements in the resonance part, but that's the only place. And now that in August the Vactrals were discontinued by the manufacturer, I'm told that Cool Audio, which is Behringer's chip brand, is making a clone of them now, so they won't really disappear. But as part of it, I'm in the future not using them for anything. The only place that I feel like it is really significant for them is in the low pass gates, where the characteristic attack that makes things sound sort of natural and wooden. I feel like they're necessary.
I never grasped where the Vactrals were in the design. Like, is it to make the sound? Are the Vactrals between the CVs and the circuit?
In case this is something that nobody understands what we're talking about, a Vactral is a small enclosed box that has an LED and a photocell inside of it already, and it's in a light-proof enclosure. And Buchla used them a lot in the 200 series for all sorts of things. Anytime you needed to add voltage control to something, he'd put one in. But the place where it's famous is in the low-pass gate, which is a module that does VCA and a low-pass filter, or a combination of the two. And the reason that they became famous, well, the reason he used them, first of all, is because they make total isolation between the control side and the signal side, because the only connection between them is light. In original Buchla 200 series, they actually had separate power supplies for the control side and the audio side, and no control voltage feed through comes through like they do in normal VCAs, or some amount. And so that means no clicking, and also they have no added noise because the photocell is passive. The reason that people really like them, in the last 10 years or so, they've really come back into being now in everything. Some brands, I mean, McNoise is advertising how many Vactrals are in the modules. The reason is because they're a little bit slow. So the same way that in an optical compressor, you have something like this using a light and a photocell, and they have soft, slow attacks and releases. In the case of the low-pass gate, you have about 50 millisecond rise, which makes this rounded attack. Even when you send just a straight vertical gate into it, you still get a rounded attack. And something like 150 milliseconds or 200 milliseconds of decay minimum, which means that it's not possible to make these really harsh, fast electronic sounds that aren't possible in nature. The only thing that's possible is something that's a bit more like a natural sound. So they describe, the attack is sometimes described as sounding wooden, more similar to hitting a piece of wood with a mallet, or plucking a string where the rise of the note is rounded off. Of course, it's possible to add a soft attack and decay to something through another means. It doesn't have to be with a Vactrol, but it's a kind of easy magic solution. You put this thing in and you have a Vactrol sound immediately. But within the last year, the company that had been making them, well, the original company, Vactech, who made the Vactrol, had been consumed by another company, and then another company, and another company, and only for the last 5 years or so, it's been, the brand's been called Excellitas Semiconductors, and in August, well, in the summer of last year, they announced that they won't make them anymore. So as of August, they're no longer manufactured. So it just raises an issue about what do we do, anyone who's using them, what do we do in the future? So now it turns out that in China, they're going to be making a clone of it anyway. So I think that they'll probably still be all over the place. But to me, they're only necessary in places where this characteristic sound is really a part of the sound.
But concerning CV or directly concerning sound applications in
I would
design?
only use them in a situation where it's controlling audio and it really benefits from it. I think there are places that I've used them where I feel like the slow nature of it is actually something I'd rather get rid of, rather than being happy with it. I don't know if we can listen, but I use a Vactrol in the amplitude and tone controller in the filter section, and I think it's really important in that case. So in this case, I think it gives a nice round tone to the attack of the notes, but
it's not a low pass gate.
no. This one, what's going on in this module, we'll talk about that next actually. What's going on in this module is a FET-based input gain stage, which is essentially a preamp, but it has the ability to clip the signal, so it's in a lot of ways similar almost to a fuzz box if you push it up enough, followed by a Vactrol-based low-pass filter that is all discrete transistors with a Vactrol. So in that respect, it's more similar to a Buchla 192, which was the low-pass filter that is also Sallen key filter arrangement, two-pole filter, but it didn't have switching to do VCA mode. And then after that, the signal goes through a VCA that's made of discrete transistors, which allows separate address in a linear and an exponential fashion. So in that respect, it can do, well, this also has the resonance path of the Sallen key filter has gain on it, so it has a resonance control. So a low-pass gate doesn't have resonance, it has a fixed feedback configuration. So in this case, if you want to have the sound of a low-pass gate in the low-pass mode, you can put the resonance control to around the middle. That's kind of what we were hearing. And just leave the VCA open. And if you want more, it has the ability to balance the input signal level and the resonance signal level together and clip them, either clip the signal coming in or clip the resonance signal, or have them fight for the space and get something which is in a way more similar to an MS-20 filter or something like that. Or if the resonance is turned all the way down, then the feedback portion of the Sallen key filter is completely cut off. So then it's only acting as a single pole filter, which then if you're interacting with the VCA, is more similar to a low-pass gate in the sense that you have the VCA action and one pole filter action happening together. You don't get the automatic ringing on the VCA side, but you get that on the filter side. But you also have the ability to control the relationship of the CV in a way that you can't on a low-pass gate. And since this VCA has the ability to be controlled with linear or with exponential at the same time, it can do a lot of things that a low-pass gate can't do. It's the only VCA in the world that can have different CVs going into the exponential and linear at the same time, and have either one going up and down at the same time, because there are a lot of people out there cloning the VCA from the ARP 2600, which is also discrete transistor core and has a linear and an exponential in, but those ins can only be used if you go up on one of the CVs, you have to go down on that same one in order to close it again. You can't put a negative voltage into one to bring down the positive voltage in the other, which you can with this. So that means that I can use one input to do amplitude modulation that's actually bringing down the other one, or vice versa.
Now you're saying it's FET based. Is it a complete op amp with negative feedback? Or?
There is no op amp in the signal path.
Okay.
The FET input stage is just a single FET with a PNP, so a class A stage, and the same thing for the output stage of the sound key filter, a class A stage, and the VCA section is current mirror and you know a long tail pair, but the output that in an ARP 2600 is an op amp is done as a discrete op amp.
Okay. And then coming back to the filter, the diodes.
Right.
The diodes are where in the chain? Are they?
It's a configuration where it's a the CV that's going to control the cutoff is turned into a complementary. So when one's rising, the other one's falling, and then the diodes they're actually transistors wired as diodes, but acting as diodes, but they're just going from the signal up and down to the control signals to change the effective resistance and creating a single pole.
Yeah. Okay.
And it's done the same way for the high pass and low pass. This configuration makes a single high pass filter, effectively making a resistance to ground by having these diodes, and that on the connected with the output of a capacitor stage, just a discrete buffer after them. And in order to do low pass, then that's in the feedback of a discrete op amp.
Okay.
It's totally different than any other filter that's ever been done, and it is messy. It has a lot of control voltage bleed through, and it's not particularly quiet. But it's so weird that that makes it kind of fun.
Yeah.
So we've already talked about the amplitude and tone controller. The scan and pan is one of the newer modules. It's not from the original ones, and we don't have stereo here, but it allows a signal to come in and to each of its 4 inputs to come in with the gain control of the input and have the volume and the panning controlled going to a stereo mixed output. But it also has the ability to blend the signals together, not just mix them in a basic configuration like with the volumes, but also to scan across them with the voltage and fade between. So the controls that we'll get to in a minute from the harmonic oscillator, the center and width, are there at the same time as panning and volume and again, all discrete transistors all the way through, so a pretty sweet sounding distortion as the headroom is used up.
So it works both ways, like 4 to 1, 4 to 2, and 1 to 4.
No, it won't act as a distributor. It'll only act as a mixer, but you have 2 outputs and you have 4 inputs. So if you choose to just pan some signals to the left and others to the right, then you can use it as separate configurations for the 2 outputs, or you can treat them as stereo outputs and from voltage pan between those 2 outputs.
Okay.
So it can be interesting with 4 signals that have each of them have their panning automated in a different way, and then they're scanned across, because then there's some stereo field that is varying in a more complicated, not pattern, but configuration. Yeah, it means smaller and simpler, but it has some tricks in that sense. Okay, I talked about it a little bit before. The voltage multistage is at the core an 8-stage sequencer, but it has the ability to turn each of the, let's use if we're using an envelope, we have the ability to decide which steps are playing, and if these, in this case where they're turned off, they actually aren't passing the voltage. When the stage is turned off, it's not actually passing the voltage from the off stages on, which means that with long decays, it's not changing the pitch as it goes off into the distance. It's just holding with the last selected stage. And if a stage is pushed to that slide position, it slides, but it slides for the entire length of the stage, which is significant because then this device can be used to make multi-stage envelopes or LFOs or whatever. The core clock, which is also voltage controllable, can be controlled as opposed to a situation like a portamento or a slide circuit where there's a control for the time of the slide that's separate from the speed of the internal clock, and they're not unified. In this case, if all the stages are in slide, then or using some of the logic tricks from this, actually keep this, it can be set up to treat this like an envelope where any stage can be patched into the sustain input here and become hold there as long as we're now holding the start button, but if a key was plugged into the start button, it could act as an envelope that's up to 8 stages long and have any stage as a sustain. And then there's also an input called enable, which can be used to make a sequence that only play, that if a key is on, it'll hold at that stage if there's not a key. So using this configuration of patching an output into enable or sustain or stop allows for some tricks to grab certain stages and make them react in different ways. And also we have the ability to use at any stage as a reset that strobes to wherever we select with the analog address control, so we can make patterns that go more or less from anywhere to anywhere, and any stage can be a slope for the entire length or a step. And
how do you change the start point?
if you want to have a sequence that stops in the middle somewhere, you can patch back from the pulse outputs into the stop input, or if you want to make it so that it stops there as long as you're holding, then you can patch that into sustain. Or if you want to make it so that it always stops there unless you're holding, then you can patch it into enable. And this can be also useful if you pick like a, if you, maybe here. Make it so that it's only playing those two, but it only plays them during the time that the key is down. So maybe like an LFO or a short sequence that only plays during the key press, or one that plays all the time except when the key's down. I don't know what use that would be, but I don't make that decision.
And the CV range from the first row is very interesting too, the very big. It's a range of CV.
Yeah, well, it's back to that same problem from before. The range of the CV coming out of the rows is 10 volts, but you need that if you want to use it as an LFO or as an envelope. You made, or a sequence for anything except pitch. When you have 10 volts on this 20 millimeter slider, it doesn't make a lot of sense to plug that into the volt per octave input and span 10 octaves in this little way. But if I want to use that for pitch, I just plug it into one that I can scale back and just turn it down so that I get a couple of octaves range rather than. Okay.
You know, also from 0 to 10 volt.
Yeah.
Down in the hospice.
Yeah, I heard.
Yeah.
But I mean, I heard a couple of days ago that it was the end. So
yeah, that's what they're thinking. Yeah. Anyway.
Sorry. Thanks for stopping in. Moving right along. We'll get to this in a minute. The multi-envelope is a dual envelope generator that puts out multiple envelope shapes at the same time, and it's the only one of its kind, so it can be a little bit confusing. So really what's happening behind the scenes is that there's something similar to if this voltage multistage is in an envelope mode where it's all slopes. But the idea came to me that if I made that in only 4 stages long, but always in slope modes, that there would be the possibility of doing a few different envelope shapes. And what if all of those shapes were happening all the time? So when it's playing, there's it's kind of hard to see or to, it's kind of hard to demonstrate, but it has delay, attack, decay, sustain, release, attack, hold, decay, sustain, release, delay, attack, hold, release, and attack, decay, attack, sustain, release happening at the same time. So in a lot of situations, you would just decide which one of those you want to use. But an interesting thing is that since they're all there at the same time, 2 different parameters can be addressed with 2 of them. So in the case of delay, attack, decay, sustain, release, and attack, hold, decay, sustain, release, it's sometimes nice to have the delayed one going to the filter and the holding one going to the VCA. So with the attack can be shaped to have a difference between the volume and the sort of double rise. But also, if it's set to loop, because there's a pulse output as well. If it's set to loop, then and the sustain is put down, then the attack, hold, decay, sustain, release, and delay, attack, hold, release are actually a quadrature pair, like a Buchla 281 in the quad mode, where the four controls are interacting to create trapezoids that are 90 degrees out of phase. Yeah.
So you can use it for the panel.
Well, yeah, if we had quad panel, you could use it for that. We don't have that, but maybe there's another. Yeah, maybe there's another use for. I don't know. And then the final mode only on the top one is attack, decay, attack, sustain, release, which I'm not sure, but I like to say I invented. It's essentially an attack decay envelope followed by an attack release. So almost like an attack decay with an echo or something like that. So this has also pulse outputs on the top of the two that are gates that are held high for the entire time that stage is on, and it has CV control of all of the sliders, and a shape control, which is it went all the way down. All the slopes are linear ramps. When the shape control is turned up, they become true RC curves, which is a little bit different than the other envelopes out there that have these controls that are exponential or logarithmic, because in the East Coast philosophy of synthesizers, the envelopes are curved and the VCAs are linear, and those work together in a certain way. But what we find is that the attack, a so-called RC curve, which is the curve that happens when a capacitor is charging over a resistor, it makes the beginning of the charging really fast and the end of the charging slow. So what you find is that the shape is more like a convex on the rises and a concave on the falls. And when you have an attack release envelope that you just send feedback around, what you get is ones that either go like this or like this, but that's never what you want, because you want this kind of shape. So this one actually has continuous control from linear to full RC curves and anywhere in between. And an extra cool thing about it is that the control, when it's looping, it doesn't change the overall speed when you change the shape. You can hear a sort of change in sensation, but overall speed stays the same. So sometimes when you see shape exponential, log, whatever controls on some other modules like this, the speed is changing like crazy as you change that control, and that doesn't have, that doesn't have, exactly. Well, that's because all of those designs are based on the surge dual universal slope generator, and they're just sending feedback back in. If they had feedback going to the rise and the inverted version going to the fall, then it would do this, but they don't.
Well, that works on the whole envelope, right?
Yeah,
Not on each
yeah,
stage or anything.
exactly. So all the rises are logarithmic, and all the falls are exponential.
Okay.
Yeah, so it actually means that when used with the linear input on a VCA, it actually can operate the way that you might expect it to. And if it's so. Also, I think that in the ARC 2600, you have this separate exponential and linear inputs to the VCA, and with the configuration, the way it's normaled, the ADSR envelope goes to the exponential input, and the AR goes into the linear input. It's the other way. Either way, you have a situation where you have an exponential or an RC curve envelope going into an exponential input on a VCA, so you have like a super exponential curve on the decay. And I believe that's the reason why people all the time say that ARC 2600s make the best drum sounds, because there's something magical about this extreme exponential decay that makes them sound really punchy. I don't have any science to back this up, but that's what I believe. So in this case, you can do that. You could actually patch the, you could crank it up to full curve and patch it. And that is something I like about the shape of those decays. Finally, the harmonic oscillator is the same discrete transistor based triangle core oscillator as both of these are, but it has a wave shaper that takes the basic core, which is this triangle, and folds it up. So it takes makes a sine wave of the first 8 harmonics. So you have and then a voltage controlled mixer that allows you to blend those together by hand, just by mixing, or with these various facilities to do kind of macro mixing, where voltages can be used. And what we find is that when these, again with the idea that you can get away without using a filter, a lot of sounds that you might only expect to hear from a filter actually become possible without. And all of the controls actually work at the same time. So So actually it's really nice for making drone type sounds that move very slowly. It's really not totally unaffected, so if it's run through some delays or reverbs and stuff, it does a really nice job of making soundscape type droning that slowly evolves and never repeats.
I find that this part of the other outputs are very effective too.
For patching back or
No,
for
both.
well, I mean,
Like as a,
these are the same, you know. But of course, in a pinch, you have them here. You could use them for something. But what a lot of people ask me is, can you patch these outputs back into control inputs of another part, which is of course allowed, but it doesn't really shape up to be as interesting as you might imagine. Or well, I could go for it. So maybe you want to take a break now, and we'll talk about the new ones.
Yes. Okay. And we have some beers, by the way, so they are on the table.
I had a few, let's see later, I had a few questions about
Bah ouais, ça
c'est
chouette.
Alors,
Alors, je vais vous ouvrir les bières.
and of course, it's my favorite, you know, sometimes I like a little bit more of this, so I'm just wondering about the you know, when you use CD input here to scan, let's say scan the different signals here, it's like, I'm always wondering, it sounds like it's switching, you know, like
It actually is fading, but there's when the width is in the lowest, then there's actually space between them. So if we use, for instance, I know what you mean, but there is a little bit of fade, but the problem is that it's a balance, because if there's more fading and we can never get it to be completely just one at a time.
Doesn't sound as like the calibration of mine seems to be like, you know, I have like wave shaping type of thing happening very, very old. It's like there's no curve, you know?
It's a bit,
Maybe I can play
there's not actually a calibration, but unfortunately it's using a configuration where it is a lot of variation from one to the next, and so there is
very nice wave shaping thing. I was thinking of, you know, having a compressor oscillator on this one, but I find that this oscillator probably this makes a very nice wave shaping software.
I definitely use it. I would say I use this more often because I think that the sounds that it can make are unlike anything else. It's not competing with any of their modules to do this because it's the only one that does this.
And also, it's finally, well, it doesn't sound at all like you know, any other oscillator. It's like you have 8 sines, right?
Yeah, and they're not the cleanest sine waves. I'm sure you noticed. Like with the odd ones, it's really hard to get them perfect. But
yeah, sometimes
it doesn't
use a filter.
Yeah, but it doesn't. I feel like that's not the most important thing. I think the most important thing is to have the ability to make change happen all the time. So
how come you have noise on the sinus? Like you know, it's like a high pitched, very high.
yeah, what's happening is that the triangle is being, for the even ones, it's just taking whatever's below the 0 line and flipping it above, like it's a full wave rectifier. So that's pretty easy to do the even multiplying. But the odd ones, it's much more complicated. There's clipping. Basically, it's taking a triangle and turning it into flat top, like a trapezoid.
Yeah.
And then mixing that together with the original in just the right way to eliminate.
Yeah.
And it's any little bit of mismatch in the components makes a little.
Okay.
So it's not so much distortion. I mean, I guess it's distortion, but what's really happening on these is that on 7, that actually what it is that any a little bit of symmetry trouble on the original triangle. So if you imagine this is a little bit tilted one way, then as you go up, it makes it sound like you have FM at half the, like 1 octave below, because all of them, you know, in this case,
Ouais, enfin, le sampling machin, là, c'est tout nouveau, ça, non?
3.5 cycles on one side and 3.5 cycles on the other. So it plays the lower pitch for 3.5 cycles and then the higher pitch for 3.5 cycles.
Yeah.
So there's a symmetry control, but you can only get it so good. You know, it's too many moving parts, and then unfortunately, it also when you move to a different power supply. So we put it on the power supply at our shop and get it the best that it can be, and then you plug it into your system, and it's not as good as it was for us. It's a little bit different.
Would you recommend a linear supply?
It depends. I'm actually using a switching power supply in here, and it works okay. But it has to be a supply that has enough current. Some of the ones out there, small ones that have ribbon cables to distribute the power, they just don't have enough power to actually work properly. So when they're struggling, the signal from here might be coming through in the power line and coming up over here, or
I can hear this is one oscillator that I can hear in my output.
what kind of power supply is
Through
it?
the 0 volt bus, I think, because it's even when I don't have anything plugged. And if I plug an output on the mixer here, I can, if I crank up the volume, I can hear this one first. But
I don't know how much I can do. I mean, I put some regulation on the
what you
input.
said previously, like maybe there's a lot of work to do about, have a better specification over the PSUs.
It's true. One of the things that they talked about concerning that is that when you power up, like it's just here sitting overnight or whatever. At this moment, all of the capacitors that are on the power that are used to get rid of noise, to clean up the signal, all of them have to charge up with power at the same time. So the draw on the power supply is a huge spike and then settles, and every module is adding to this spike. So if you look at modular grid and you see what the current draw, maybe on this one I think it's 220 milliamps on the positive and 120 on the negative, something like that. That's just a sustained level. So at that power on it might be 3 times as much. And then all the time people tell me that they're having some kind of problem, and I have no understanding how they can have that problem. And then they tell me they're using a tip-top micro Zeus supply, which based on the numbers, like the supply tells them the negative rail can do 400 milliamps or something like that. But there's no way it really can, and it certainly can't do it during the startup, so your problems happen. And then
in transportable cases, you have to use a pretty,
exactly.
Linear is pretty
And
heavy.
these can be plugged in anywhere in the world and always work.
Of course, yeah. I use 4MS for
And that should be a good one.
Yeah.
But
and I use a lot of them. Like at first I used like maybe one for power all this, like 104 HP, and now I'm like dividing and getting more to get rid of the noise. Sometimes it seems to be better, but well, I don't have like a very big problem with noise.
Mais en CV, c'est moins important que.
But still, I think it could get better. Like in general way, it could get better. Like
I agree, but we have, of course, that problem of the weight, and the ability to use it in different countries, and
then the ribbons too.
The ribbons are terrible. The connectors, the labeling, so many problems.
Mm-hmm.
I don't think that the ribbons are going anywhere. I think the ribbons.
I had to cut like two connectors like yesterday. I nearly made a big mistake on the Jamox module because I have shrouded buses. So I was like, oh no, I shouldn't do that.
Well, the other day, Dieter Doak first said that he was using the boxed connectors at the beginning, but he was using the opposite way of some other brands.
Oh, right.
So now there's a problem that they could develop a standard. We could declare a standard, and then some modules from before are the opposite of that standard. So
you can't force people to apply. Right?
Exactly. Well,
especially for you have like a lot of old, I believe. What's that brand? Very good modules. Tu sais, ce fabricant qui utilise le truc toujours à l'envers. C'est-à-dire qu'on Schwemmann, yes.
And nobody can pronounce that either.
Yeah.
Schwemmann.
No, it's a Polish name.
Yes.
He's in Sweden, but he has a Polish name.
And what is the real pronunciation?
Schwemmann.
Schwemmann.
That's probably wrong too. I don't know.
Just a little question.
Mm-hmm.
The oscillator exactly the same.
The inside, yeah, the core, the basic part is exactly the same. But the wave shaping is where the difference is. So in this case, the starting point for the core automatically does a triangle and a square. So the sign here is identical to the sign right here, the first one. But then the triangle is, in this case, all the other shapes are created and then it's blending between them to get this stuff. And here, the shapes, it's just brought out in the way. So,
Okay, but
but the core is the same. And the core is based on a triangle core and it's discrete transistors. So it's actually it's stable enough on the long time, but in the short term it's not perfectly stable. It's a little bit like wavy or shaky, which we find makes it sound really soft and really organic, and people seem to like it. I like it.
Là, ça supporte bien. Par contre, une ligne, une bassline ou un lead, tu vas pas mettre 10 octaves.
Non,
Mais sur du rythme, je trouve que ça peut être intéressant. Je suis habitué à la touring machine. Moi, la touring machine, elle va avoir 10 bits.
When I watch this,
Et quand j'ai acheté mon
you know, that's random, and it's like a trance that I get into. I watch it and I
Non,
can't
merci,
stop. It never repeats. So it's like watching a candle burn. And then the flames.
non, ils sont pas d'accord. Actually, when were you able to send us new modules?
Alex 4 has them now.
Okay,
They just received them this week,
okay. So we will order them.
but in not a big supply, so I don't know how long they have it.
Okay.
Maybe it's hard, but we should. Well, we're going back home on Monday, and we should have a second show by the end of next week. So within a month, there won't be in short supply, but
We will.
today maybe it's competitive. I don't know. Maybe they all go to Schneider as well.
But okay.
No, I don't know how they decide how they're distributing it.
Oh, I think it's equal, but no. Okay.
They make a really big point out of how they can't favor. They're not the same company, and they can't favor
Yes.
their own Germans.
Mm.
I think it's the law. They
They
have to
yes.
separate everything and
Mhm.
make sure that they're not offending anyone that they sell to.
Yes, absolutely. We know that because it's quite the same for us with music, and so we try to not to mess something like that.
we didn't get over the random module.
No, we're going to talk about that when we get started.
So it would be nice at the end. Are you ready to play a little bit to do some things?
I can do some.
Okay, cool. Do you?
It'll be quite boring because it's just this instrument. but-
Can you trick some drums with that? Because I have a system for you. I have some tipped-up drums there. You can take if you want to add some things. And I don't have any sequencer. I have the second, but I
Why don't we just do the boring 10 minutes or 15 minutes and just that's enough.
Okay.
Just to show what it can do a little bit.
Okay. But I think it would be interesting to, for example, tomorrow you're going to play live. So what choice did you make? And it will be only your system and 99? No effects.
Yeah.
Effect processor. Okay. So it will be nice to explain that. And it should be total improvisation, or you already know.
Total improvisation.
Oh, okay. And you play how many minutes like this?
An hour.
1
60
hour?
minutes.
60 minutes with your system? Okay.
But I've done this
Yeah, a million times.
hundreds of times.
Yeah, sure. Mm. I think.
Only this system? No.
And a TR-909.
Okay.
Which, I could do the performance with just the
Yes.
TR-909.
Yes. And because it's funny because I was today a lot of people are beginning to use 100% live with modular. So you have to, you can mesurer, comment dire en anglais déjà. You can expect, for example, with a 6U, you can say, okay, I can do 30 minutes of music with, well,
You think that there's
estimate.
You think there's like a certain ratio of like how many rack units you need to have for each minute?
yes, because
For example, with one module, how long can you play with one module? You know?
before it begins to
I
be
can play for
boring,
10 hours.
not
One
so
oscillator.
repetitive. And because when I also live I've seen right now, it's you can do some tricks at the beginning with some drones, ambient synths, and then bring the rhythm. But I think it's the 45 minutes. It's a good for if you have a 9U.
45 minutes.
For a 9U, it's quite the
45 minutes for a 9U, so
Yes.
like 15 minutes per
No,
3U line.
If you make a live with drums and bass and beats, but it's just the beginning of something I want to dig it. But I think the subject is very interesting. How you play, how many times you can play with a system that is quite small without being boring at some point. So it's I like this
one
subject.
man's boring.
He doesn't know when
I was under the impression it was really interesting when we.
But I like it. I think it's a good subject. And because some guys are making techno like they can do the same rhythm, the same thing, and going, it can be boring, but it's not.
Yeah, well, if they were DJing and the records they were playing were just going, you know, dong, 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 dong,
Yes,
dong, dong, over and over again.
Yes, yes.
It's no problem to come up with something like that, you know, over and over again.
Well, so if you want to speak about that later, well,
Yeah.
not about this subject, but how you play live.
Yeah. I did a talk, something like that at Super Boost.
Oh, okay.
Talk about how I do the performance parts I use, what the patch is like, and then also what I'm thinking at certain times to try to see it falling apart.
Yeah.
Moi j'attends de voir un peu si.
It's kind of nice to see what you can twist on.
Ouais, mais tu sais que moi j'avais vraiment un petit peu d'avance. Et en fait, je pense que je puisse faire ça. Alors, Resman, j'ai l'impression que t'es quand même assez limité. Alors que sûrement
C'est un Resman ou tu passes toujours le temps dedans?
Ah non, c'est Accelerator. C'est Accelerator.
Je sais pas si c'est vraiment un écouteur en rien.
He's actually just asked me to talk about this, so we'll just wait.
Okay.
You show the run up something? No, I will do that right after. Because I have two new models this week. We made a shipment at the end of last week. They came to Germany, so I think it's possible you could have them here next week.
I think we will order them at the beginning of next week, so it could be fast.
Okay. So last week we were in Berlin for the Super Booth event, which was our replacement for the Musique Messe, and during that show, I was showing two new modules, and those two new modules are the sequence selector and the random sampling. So sequence selector first, it's a pretty simple module, but it does some kind of unique things. So it's a 5-stage analog sequencer that allows you to jump to any stage directly from a button or from an external pulse.
So it's inspired from the 245?
Yes, but it does some different things too. So every stage has a pulse out and a pulse in, but also buttons. So it can be used in that conventional way. Just but that's not so interesting. It's a 5-stage sequencer. But also it has a transposed input. So an external sequence can be passed through it. And offsets applied. And this can be automated so that it can be treated like an arpeggiator. Which allows, like an arpeggiator, to take a pattern and shift it up. And it could also be done the other way, with this one doing the sequence and something else doing the transposition, like the keyboard. But also, there are 2 5-to-1 analog switches built in, and those can be used to, for instance, to take the 2 rows of this sequencer and to make a longer sequence. In this case, the 2 are chained together to make a 16-step long signal sequence. Unfortunately, we don't have enough switches to make it full featured all the way across, but it's a possibility. But potentially, this could be, with the 2 5-to-1 selectors, you could chain as many as 5 dual row sequencers together to make a longer one, or if you don't actually step them along automatically like that, they could be manually selected. So during a performance, it's possible to put in manual variations. But also, there's really nothing that says this has to be for selecting sequences. The signals going into the selector could be anything. They could be control voltages. They could be audio signals.
It doesn't have its own clock. There is no clock.
There's no clock internally, but for most of the things that it would be used for, it wouldn't need a clock anyway. These switches can switch signals well into audio range. So one question that I was asked last week is if it could be used as a selector for stereo signals. It could, where all the lefts are plugged into one row and all the rights are plugged into another one. It's good for selecting control signals, like having different LFOs playing in different places and select between them manually, or the individual stages can be selected at different points in outputs. whatever. It also can use analog select. So like the Buka 245, it can have an analog voltage come in and select which stage, which actually then allows it to operate like a wave-shaped drawing. Or to, with voltage, select which you want to hear. So okay, the random sampling is
You can do all that with the voltage.
well, you don't have the selectors. You don't have the ability to take signals and select between them, and you don't have the ability to manually jump to a stage. You'd have to maybe advance to it or reset to it. So it's a little bit different way of addressing it. It's, I think, pretty nice for treating like a programmer, you know, like the surge sequencer programmers, where you can have preset situations for your modular where you want to have different scenes. You can grab them, so you can, with that, have a CV for the scene and 2 modulators for that scene. So it can be kind of powerful, and in a live performance situation, it's really nice to be able just manually jump to them. But you also have the ability to, with analog voltage or with advancing or with an external pulse jumping to them. So it's kind of flexible.
So the best is to have both.
The best is to have everything. Okay, so the random sampling, obviously based on the ideas that came from the Buka source of, or were in the Buka source of uncertainty, but it does a few things a little bit differently, and some new twists. So the topmost part of it is what I showed before, random varying voltage that's voltage controllable, and can go from really slow, about 1 update every 10 seconds, up into the audio range so far that we can actually use it as a sweepable noise generator. And if we program something, because we have these reversing attenuverters, we can there's also a random gate, which, in addition to making this cacophonous lo-fi noise, can be used to randomly trigger an envelope, which the random gate is totally uncorrelated from the random voltage, meaning it's not set up so that when the voltage is high that it turns on the gate. It's correlated in the sense that it's one control, but they're not. There's no pattern to when the gates come on compared to what the voltage is. There's also familiar from the Buco source of uncertainty is the quantized randoms, which are every time a trigger comes in, they select a random voltage. What's different in this case from the Buco, so it's actually digital. It's grabbing a 6-bit digital word, and this control is selecting how many of those bits are playing for the possible voltage choices. So when it's all the way up, the top jack, the 2 to the n, is 64 possible states, and this lower jack is only 7 possible states. But as the control is lowered, fewer bits are involved. So at the bottom, it's just 2 possible states, or 2 possible voltages in both cases. What's different from Buco 266 and this is that this isn't a pseudo-random sequence generator that plays a loop of all the states in a row. It actually never repeats, no matter how long it plays. So you're only adjusting how many possible states there are, but you're not adjusting how often you're going to hear the pattern, because it's truly random. Every time it plays, it is picked out of a hat, basically.
It's 10 volts out. It's 10 volts.
What do you mean? Is it
Voltage out.
well? That's what this is. This is just a set of voltages. You're just hearing the oscillator. So this could be anything. It could be I don't know.
But the question was, how many voltage?
The range?
Yes.
10 volts. Yeah, and it's quantized in the sense that there's steps, but it's not trimmed to a volt per octave or something like that. It's just covering the range.
And it's unipolar.
Unipolar, yeah, 0 to 10 volts. We have noise in white, pink, and metallic, which is 6 detuned square waves, like in an 808 symbol circuit. So if we high pass filter that, and we why are we not here? Oh, I didn't plug it in. Oh, and then we have a 4-stage analog shift register. So 4-stage analog shift register is a bank of 4 sample and hold circuits that are in series. So when an external CV is coming in, the first sample and hold, and a gate is coming in, the master trigger input. The first one is acting just like a sample and hold, and then the second one is grabbing the voltage that used to be on the first one, and the third one is grabbing the voltage that used to be on the second one, and the fourth one is grabbing the voltage that used to be on the third one. So this can be useful in certain musical contexts where you want to delay a control voltage from one voice for another voice and make sort of control voltage echo. But when the circumstances actually don't require a analog shift register, any one of these individual sample and holds can be broken out to be used as a separate sample and hold. And that includes the CV and the gate input of that. So, for instance. I don't know if you can see it, but as the first three go through with a green triangle wave going through, the last one's just doing whatever. So all four could be used for totally unrelated things, or one could be used for its own thing, and three could be used as part of the analog shift register or whatever. And also, because of the nature of the way that analog shift registers are made, the trigger from the master trigger input, when it is pulsed, the four sample and holds are actually triggered at 4 unique times, delayed about 500 microseconds apart. So if we plug the same random signal into all of them, and it's fast moving, when we pulse it, it's actually grabbing 4 unique variations. So in a case where you just want to have as many random voltages as possible, you can use this section with the same signals malted out 4 ways to get 4 uncorrelated random voltages. So then you can use these 4, these 2, these wavering around, whatever, and make something where every time a note plays, it's completely changed from what it was before. So that's it.
Can you clock separately all the different random schemes in the model?
Yeah, well, in the quantized random section, the two outputs are related. They're on the same clock.
Mm-hmm.
If you want to use the 4 in the sample and hold section separately, you can do that. They're all independent. There's the master input that's sending a staggered delayed trigger across all 4,
Mm-hmm.
but they also have their own trigger inputs that are, when they're plugged in, they break the normals. And these 2 circuits are independent. The top, the fluctuating randoms, can have their own whatever CVs going to.
Good.
Good.
Do you have any question about what you have seen tonight? C'est le moment de poser des questions, si vous voulez.
Yeah.
I think it's
One of the things that we were talking about on the break is about the performances that I do, where I just use this box and TR-909, and
because he's playing tomorrow at a party in Paris.
Yeah.
Paris.
yeah, it's in some sort of rave situation. It's in a warehouse or something. The party's called Off.
Off Anniversary. L'événement s'appelle Off Anniversary, mais le lieu est secret. The location is secret, right?
No,
No?
so
Not
it's
anymore.
a car park.
Okay.
Parking.
So-
Saint-Denis.
Ça, c'est maintenant.
Ah, yes, Saint-Denis, à côté du Stade de France.
Ah.
Okay. Near the stadium. Yes. Okay.
This will be a big venue.
It's a party that's going on for a really long time too, so you get your money's worth. So anyway, one of the things that Cyril wanted me to talk about, and we also almost touched on during the break, was how I do those performances, how I'm using these modules, how I connect everything together, and maybe what's running through my brain while I'm trying to do the performance. Briefly, the way that I generally, well, the first thing that's important, I guess, is that it's different every time. So it's not some kind of prepared performance that I rehearse and do the same each time. It's more like the big rehearsal, the lifelong rehearsal to get to the point where I'm comfortable with the tools. Obviously, it's a bit easier for me to be comfortable with the tools since I designed them. But I was doing performances similar to this using other equipment before I was my own manufacturer.
So you use only 909 on this?
And
No reverb?
a little effects processor.
No effects?
No, some effects,
Okay.
but that's all. So what I do is I start with some simple patch, and usually my like basic setup is that I configure it so that the complex oscillator is the primary voice that is controlled by the voltage multi-stage sequencer going into usually this envelope on the multi-envelope, and that's maybe going directly to the amplitude and tone controller, and it's controlled here. So that's has the flexibility to create some variations in what the synthesizer voice is, and I step this sequencer along from the trigger output on the TR-909, so that if you program the rim shot, you have a trigger going out, and that plugged into the advanced input will step this forward. And so that's just like the most basic arrangement. And then I'll also make a voice out of the harmonic oscillator going into the mixer, and have the second envelope on the multi-envelope going in maybe to the width input, or maybe the center, but probably the width input. And actually that allows this to it allows this to not need to have its own VCA maybe, so it can already do some and then as I can start out just with drone things or whatever, but this, because of the nature of this oscillator having so many parts coming out at the same time, it can actually be used in a way like for multiple things at the same time.
You say that at first you said that you use the VCA with the complex.
Yeah, I'm only doing that because I need to have a gain control for the output going into the system right now. This would plug in. This would go into my mixer where I have control.
So you use harmonic as in drone mode.
Yeah, to start out, that's a good place for me to start, just as a basic like introductory thing. Or it's really helpful to run this through some effects, some delays and reverbs to create an atmospheric kind of lingering, so that when changes are made, they slowly evolve.
How much can you last with this configuration?
But just this patch, not that long. No, I'm playing an hour. I have done more than that. Depends on the situation, because certain places are a lot more tolerant of minimalism that lasts a long time. But the nice thing about doing a performance in this way is that I have certain limitations about technically what I can do, but I have the flexibility to change what direction I go with it at any time. So in a way, it's a limitless, versus like in the olden days when I was doing a DJ set and I only had some amount of records, where if I got to the place and started the set and it was clear that it wasn't going very well, I had no ability to change my plan. I'd already gotten there. Whereas with this, I actually am in some way interacting with the moment and with the people. So if something is really working, then I can continue in that direction. If something's really not working, I can end it and go with something else. So we'll do this.
But this sequence can make a really good second kick with the 909.
Yeah.
Nice.
An interesting thing is that these the pulse outputs on here are floating diodes, so they actually can be plugged into a passive multiple, and combined together.
You mean they're like a buffer?
No, meaning that at the output, they're diodes, an electric component, that don't have any, they're just floating, they're not going to ground at all. So you can plug all the inputs, the pulse inputs always have some connection to ground. So if you combine multiple gate outputs together with the passive multiple, then plug that into a gate input, it just acts like an OR gate, like any of them. When any one of them goes high, then it'll. So right now that rhythm is just taking three outputs from the.
Exclusive, so you don't have to worry about the level of.
Yeah, I mean, these are putting out 10 volts, and the envelope triggers higher than like 1.2. So if it's interacting and making a little bit strange, doesn't matter. What is this now? Oh, that's fine. Oops. But you
Yeah.
can see how and then the problem comes when it's time to transition from one thing to the
Yeah.
next, and they have to try to make a creative way to do that. But
How do you deal with that? Do you actually repatch a lot in your...
I wouldn't say a lot. I try to get to this basic point where there's like two voices that have the ability to get out, and then what I repatch is control side, like to get some, you know, the different thing to do something, and sometimes I'll work with one row of the sequencer controlling the pitch of one thing, and the other row controlling the other thing, and sometimes I'll change it so that what's happening on this one, it doesn't actually change in pitch because there are enough different pitches coming out of here that I can make some kind of blend, and then I'll use the second row for a modulation thing, or you know, in desperate times call for desperate measures. But you know, I have some bag of tricks that I can pull out ideas from. So what I said at the presentation at Super Booth was that that I use patch memory, but that it's just, you know, the original patch memory. So you know,
block,
yeah, well, I just have in my mind like things that I've done before that work okay, so I can try to get to those.
So it never gets out of control?
Sometimes it gets out of control. Sometimes it doesn't go that well. Sometimes I'm standing up there really sweating and it's not working. You know, I mean, it's working, but it's not, you know, it's not doing what I want. I'm not getting the right reaction or whatever. But
the big sound system, the thing is not to drive people deaf.
yeah, that's also a problem, to try to keep the volumes under control. But I think the fact that it can go really wrong is the reason that it's interesting.
Yeah.
Because
but wrong, sometimes it's wrong, you know.
Well, sometimes it's bad. There's no question about it. I'm not. I'm human.
Like it's not.
But
that's like it's not good to the ear. You know? So
right,
it's
right.
modular, so you can go.
Right, but I think that I think for an audience, or for even if I'm the audience to someone else, the only reason it's interesting to pay attention is because it's special in that moment, and because it might go wrong. You know, it's if it's already prepared so much ahead of time that there's no chance that, you know, that it could be terrible, then who cares? You know?
And I think it's very interesting to see how the guy can, when it's go wrong, how it done it to do it right.
Somehow that's when that's what separates the men from the boys, right?
Yeah.
It's just part of what it is.
Sure.
And I think that's interesting enough, the flexibility and the chaos of it, that recently a lot more of the people that I've known for a long time through techno stuff have started to use instruments like this, not specifically mine, but you know, modular stuff in general, because there's something special about that danger or
that's why you get sound.
Unpredictability of the situation. And of course, a lot of it, when you're using a modular, a lot of the time, in studio anyway, a lot of the time you are trying to get somewhere that's something usable. You know, a lot of it is trash that you're trying to work out of. And you don't have that option if you're, you know, on the sound system doing it. So it makes it a lot more, you have to think before you do the patch, you know, and that can also be kind of an interesting situation to put a person into. I know of some performers who are more experimental, not quite so dance floor oriented like what I do, who actually do performances where they don't even start with a patch at all. They just start with an empty system and just start patching. And I think that's even harder.
Yes, because it could be very boring.
Yeah, but if you have the crowd,
The start is boring.
the problem is
Well,
the
I
crowd.
think that sometimes in their case, they don't have the crowd, they're playing somewhere that's small with only a handful of people, but people who actually want that
Yes.
experimental nature.
Yeah, of course.
I had a situation actually in February. I played in Bergheim, and I had not this case, but one about the same size, and it was brand new, and I had an empty space over here, like where there's a multiple right now, and I did a sound check, and everything was great, and I went to dinner and slept, and then came back to the club, and imagine the table was just covered in beer bottles all around, which was fine, sort of, except that
There was a
when I was standing around by the bar not worrying about it, and then when I went to start, nothing was working, and I was unpatching modules, trying to figure out, standing on a stage in front of 1,000 people, trying to figure out why it's not working, and then smoke was coming out of the crack between, and this module was actually had just fried or melted down, which is a terrible situation to be in. But coincidentally, there's guys from Romans who just played right before me. In fact, they were still playing while this was going on, had that module in their system. So we, on the stage, took it out of their box and moved it into mine, and I started. But that all of that chaos meant that I started without preparing anything at all. And what I realized just like 2 minutes in was that all these controls were set into a way that was making it do something that I wasn't expecting. I mean, of course I can figure it out, it's my design, but I started with it totally messed up in a way that I had to try to recover from. So it's definitely helpful to at least, get it to a point where you know what you're dealing with, you have it all to a sound that's under control and to a tuning range that's under some kind of control.
So how did it go?
The beginning, not that well, because I was trying to collect myself and trying to recover from the, I don't know if the people noticed that. I think that for them it was fine. In fact, for them it was probably better because they saw all this panicking and then it was working, so then it was great. But for me it was pretty hard to get focused after all of that panic. By the end it was okay, but at the beginning...
It's a good place for the kind of experimental thing.
Yeah, I think as long as the kick is really loud, it's okay. But no, I mean it's the best place for me to play, I think, because it's an open-minded place where you can be just experimental or aggressive, and it's okay. But it's just trying to get. I mean, focus is a really important thing in that kind of situation, and if you lose that at the beginning, then trying to recover is really hard. And it's never good for focus when smoke's coming out of your equipment.
Yeah, no. Okay, so right now, what do you miss in your system? You want to achieve with maybe another module from you?
Well, yeah, we're going to keep making new stuff. I don't have anything that's almost finished that will come any day or something like that. But some of the things that I use in my Buchla system, or that I have built before, that maybe I would start to try to find, not necessarily make the same thing, but make something like, is that there was a Buchla multi-tap delay that was never really completed as a Buchla project, and I did a lot of additional engineering to get it to be something that could be built. There are some problems with it, that it's quite noisy and kind of very difficult, I should say, to build. So I can't really just take that design or I can't, but I shouldn't really take that design and put it in here. But I would like to do something with that idea, with a multi-tap delay, and some mixing of those delays. Some really interesting things can happen with 8 there, and that one there's 8 delays. So some really cool spatial effects can be done with it, feedback and stuff. So I'd like to do something with that, maybe a combined ambience processor that does some reverb ideas and some delay ideas. Maybe something with fixed filters. There were a bunch of Buchla fixed filter banks that were interesting for all different reasons, and I have 3 of the 5 in my collection, so I have some experience using them, and I can tell you what things work nice with them and which ones don't. Also, I don't know what else is really missing, but I think I think that as with the change with the Vactrols, I might in the future try to think about ways to do things that are interesting but don't rely on this part that when it disappears, that the module becomes impossible to make. I think that it's a good challenge to a designer to think of new ways to do things that are unique and interesting. I have a couple of ideas floating around that I don't really want to talk about now and not deliver. But yeah, I don't know, maybe that's all I can say.
Yeah, okay. Great. I think maybe we can stop that. Do you have some question more to ask?
Are you happy with the song of Verbos?
The sales? Yeah, very happy. I think that we're not in the cheap range, we're in the more expensive range, so we can expect that we won't be the biggest seller, but we're very strongly in the middle and really pleased with it. And because we do it all in our factory, we have independence that we're really happy with.
How many people is working for Verbos?
Well, Sonia, who's here, is the manager of the mostly of the business portion of it, but also pushes all of us around in the shop. And then we have now myself, obviously, but then 3 other people who work. Yeah.
Okay. So you're
5 total.
Well, you're the only one in charge of the design.
I do all the design, and I do some of the manufacturing portion, but yeah,
The technical part is yours.
yeah, and actually the graphics and the technique, everything of
You
the
also
design.
designed the graphics.
Yeah, and I think that's important because philosophy-wise, I think that the graphics and the interface is the most important part, and that part should then inspire what the electronics do, which means sometimes it's a lot harder to make the electronics because they have to match up with what the idea was. I think that usually electronics are designed the other way, that the circuit is invented and then they try to figure out a way to make a package for it, but that's not a musical way to do it.
Okay.
Oh,
Why did you need to build your own modules in the past?
why did I need to?
To excuse my English. Why did you want to
Start this business.
Yes.
Well, I've been involved with lots of synthesizers over the years, but right before I launched this brand, I was doing just custom work one at a time, making modules for Buchlas and repairing Buchlas and that sort of thing. And when I did performances around that time, I did a couple of performances using my vintage Buchla, but I don't. Well, first of all, it's this big, so it's crazy to take out. But I have a small 200E cabinet, but I don't really want to take that out, so I use a lot of other synthesizers, and so initially Sean from Analog Haven started to put pressure on me. We got to know each other from the trade shows and the group meets and stuff like that, and he kept telling me that I need to bring the ideas that I had to a wider audience. At that time, this already started maybe 6 years ago. So at that time, the momentum was really just starting for the Eurorack world. In my opinion, the most important reason that Eurorack is a revolution is because finally you can make a system that has different brands of modules in one box. Because before, whatever brand you bought into, then you had to just deal with whatever that one brand made. And also it's significantly less expensive than historically modular stuff was. So I started to, based on his recommendation, I started to think about what I would do in that format, like how would I do something of my own. So I started to draw up ideas, and so my idea was that I wanted to make something that worked in that world, but that was driven by the idea, the idea of making things from the interface first, and also have something that was a bit more precious or a bit more beautiful or feels serious. So try to balance all those ideas together, and that's that. So now a lot of people tell me that they only want to put my modules in their box. They don't want to put it in together with other modules. So maybe I didn't do the best job of becoming a part of the revolution, but it is compatible. So occasionally you do see like one in the group. It's just that they look a little bit different because a lot of times it's just like
The red knobs.
yeah, and that they're powder coated in silkscreen and not metal photo silver. But I'm really happy with where we are on this. So, I don't know if that answered the question, but
Where are you from? California?
New York City.
New York, sorry.
Yeah.
So East Coast.
Yeah, East Coast, West Coast philosophy.
Okay, so I think we are finished right now. We'll spend some time together. So we will say goodbye to our friend from Internet. So thank you for being there. Merci à tous d'être venus ici. J'espère que vous avez appris beaucoup de choses ce soir. Thanks a lot for being there. It has been very interesting, and we have a very good time. So, see you, goodbye, and maintenant on va avoir quelques instants pour discuter encore un petit peu. Et voilà, merci à tous d'être venus encore. Merci.